Okay.
This call is now being recorded.
Good. Yeah. So let's start with some like decision tree regressor initially. Hashtag. I'll save this. I'll save this on the computer with the name teaching decision tree. Okay. I'll just apply decision tree. Right. Okay. First, we'll take the previous template. What we have done, like for the polynomial regressor, right? Polynomial regressor was the last template. Yeah, so I'm going to copy down the same thing. We are going to apply our decision tree regressor, whatever we have in Python, and we are going to apply this decision tree regressor to. Sorry, we are taking this position salaries data set, and we are going to apply decision tree regressor on top of that, and let's predict the outcome. So till here, it's everything is same, right? Till here, everything is same. Only our regressor will change now. I mean, the regression technique, the regression algorithm will change. Right. Okay. Let's start by checking the data set. The entire thing, so it will not get confused. Okay, good. Yeah, so now we have DF, the positions, the level, and the salary. Yeah, this was the data set which we have performed like regression analysis on that, and we have predicted the outcomes. If you remember, like we have taken this data set on top of linear regressor, and we applied algorithms like polynomial regressor also on this data set, and we have predicted our outcome, right? Like we have seen by generating a chart in the Excel initially, and we saw that there was a curvy pattern present in the sheet, present in the data. So we thought linear regression will not best suited for our data set. So we went for polynomial regression. Okay. So what happens if we move to decision tree, a more complex algorithm, decision tree. Okay, decision tree is something where it uses entropy. Entropy in the sense where it captures the maximum data, maximum amount of information. Okay, think like this, like it divides the entire data into in the form of groups actually. So the maximum the information where it can find inside a group, it like it makes a bunch like that. Suppose think like this, if there are 10 data points, it is creating like 3 bunches. Out of the 3 bunches now, it checks about the entropy part. That means the maximum amount of information of the data points wherever it identifies, it pushes that into that group. Accordingly, it predicts the outcome. That's how the decision tree regressive work actually. Okay, so let us start like by taking by taking the decision tree module from the scikit-learn, and then same thing, like we'll create a layer, we'll create an object of decision tree, and we'll try to apply the decision tree on top of this data set. We'll train the model, and then we predict the outcome, the same process. Is that clear? I mean, if you have any doubts still here, no, you can ask me, because the steps, whatever we are defining, no, these are the ultimate steps where you are going to do it actually. I hope everything is clear with you guys. So we'll start with decision tree actually. Okay. So previously what we have done, like, yeah, okay. So previously in the polynomial regressor, what we have done is we haven't applied any data pre-processing techniques because the data was so small, right? The data was so small. So that's why no need to apply the data pre-processing techniques and all. If you find like millions of data points in your data set and all, so these are like fundamentals, right? That's why we are teaching you with small data sets. But what happens when you like enter into the real-time world and you like go for the data sets and you work on the data sets, and also that doesn't involve small, that doesn't involve any small sets and all. So it involves large sets, like maybe at least 1 million data points, or at least 1,000 data points will be there. 1,000 data points will be there. Okay. Yeah. So how to apply our decision tree regressor? So see, the PLR. For PLR, you are taken linear mode or import linear regressor. In the same way, we can apply from sklearn dot tree. Tree is the like the structure where you can access your decision tree regressor actually. Okay. Import decision tree. See, so decision tree classifier and decision tree regressor is showing me up. That means the decision tree can be used for building regression algorithms as well as classification algorithms also. Okay, I'll teach you like how the decision tree takes the data into picture and how it splits the data and all in a clear view when we enter into the classification. But for now, remember, like it based upon the amount of information, it generates some bunches of data, And in the bunches of data, wherever it identifies the maximum amount of information is available for a new data point, it predicts out from that average value. Okay, remember that sentence. Okay, same thing goes with the other algorithms also. Like I'll tell you. Okay, so first we have imported our decision tree regressor, and now we need to create an object for our decision tree regressor. That means a mask kind of. I told you, like in the same way in the data pre-processing techniques. Like for example, missing values. For identifying the missing values, we have created an object called imputer, and then we have superimposed same thing. Same thing is going to happen here. Okay, so now we will create a variable. Yeah, regressor is equals to, for the regressor, what we are going to do is we'll apply our decision tree regressor and apply this random state. So equals to 0. If you remember, right, we have applied random state for train test split method, because we don't want the values to be changed whenever you execute again and again. The values need to be static, right? So here also, if it is creating bunches of groups, I mean, like it is creating, it is dividing the data points into groups, in the sense the group should be same always. It shouldn't change, right? So for that sake, you keep this random state is equals to 0, right? Yeah. So random state is equals to 0. That's it. And then you fit it, regressor dot fit x comma y. Okay. So I have created my decision tree. See, decision tree object is created now. So I'm going to fit my decision tree layer on top of this x and y. Yeah. So decision tree regressor is created on top of my x and y. So automatically the entropy values, whatever are created automatically in the backend by this package and all. So now what we are going to do is, like, we'll predict out the outcome. Okay. So in the PLR, first we'll hold on. First I'll execute this PLR also. Good. And yeah, so this is my test array. If you remember, yesterday we have taken the 6.5 value, right? So if I execute this, the linear regressor value is 158862. We'll copy this and we'll paste it here, like PLR prediction is 15862. Good. 15862 is the prediction there. Now we'll apply the same 6.5, the test value, like to predict out the whatever the new value. The new value is 6.5. We'll try to predict the value of 6.5. Like what is the salary of that particular level if the level is 6.5. Okay, we'll try to predict it, and then we'll see the results for our decision tree. Okay, good. So this test. So remember, guys, why I am giving this reshape is, so since there are no elements in the form of data set, there's no data points in the form of a data frame actually. So if you take a data frame, obviously you'll be having rows and columns, right? So if you take an array, only one value will be there. It's not a data frame actually. It's a kind of vector there, right? So in order to make sure that machine understand that it has a row and column, that means we are converting that into a row and column. We are reshaping the matrix, the vector. We are reshaping the vector into rows and columns. So for that sake, we are using this dot reshape. So once the reshape is done, automatically you can predict the outcome. Like, I mean, the machine will understand that is the right format of data where it can understand it, and it will give you the predicted result actually. Okay, remember that. Okay, I'll do it. Yeah, see. So the decision tree has given you, I guess, 33. We'll copy this and we'll save it somewhere. Oh, shit. I'll write it down. So hash decision trees value is 330378, which is bad, right? I mean, polynomial regressor has given us the best fit for this data set actually. I mean, compared with decision tree and polynomial and linear regressor, yeah, out of all three, PLR is in the first position now. PLR has given you at least somewhat accurate result, because see, if you check the data set, the 6 and 7 as the numbers from 1,50,000 to 2 lakhs. So what is the use if it predicts more than 3 lakhs? That means more than 8, it is predicting the result. That's not good. So PLR has given us so far, I mean, at least it has given us a near accurate score actually, right? Yeah. So we can assume that till now the PLR is the best suited algorithm for this data set. Okay. Yeah. Now we'll go with. Okay. So I'm saving this. let us visualize the graph, because visualizing also you need to understand, right? Like how the decision tree is visualized. I mean, some part of algorithms we can visualize directly. So we are going to visualize as much as possible. Okay, since we have fitted down everything is done, so we are going to apply the decision tree and all. Yeah, since I told you the decision tree is divided into groups and all, so we need to create some kind of grids in matplotlib actually. So first we'll create those grid for smoothing the everything, it takes the points in the grid and it smooths the curve and all, so that we'll have a clear picture on the plots and all. Okay, this is not the plot. The PLR was the plot there actually, so we'll take it out. Yeah, so now we'll start with our decision trees visualization. Hashtag visualizing the DT all go. Okay, so first we'll start with our X grid. As I told you, to smooth the curve and all, we do require X grid here. So we'll use np.arange since we have seen the range function. Okay, so till where you need this X and all. Okay, so like we need X till minimum of X, comma maximum of X. So based upon the resolution, you can decide actually how many data points you require. Like I'll go with 0.1, like go with 0.1 resolution and make me a grid kind of, so that we'll have a clear understanding. We'll give 0.01. It's good always. I mean, the minimum value is always good. Okay, then we'll reshape our grid actually to make machine understand. Okay. X grid dot reshape. So length of the length of X grid, come on. So this is like you're applying the reshape dynamically, because you don't know the length of X, for example. So if you write down the length of X grid there directly, so it will take the value, how many elements are present inside that X grid, it takes that value and it prints the grid. Okay, now first we'll apply plot.scatter. Yeah, the actual data points, whatever are there, we are plotting it in the form of a scatter plot, if you remember. I'll go with X, comma Y, and we'll use the color to it as red, because to have a clear picture, like to differentiate the prediction line and the actual data. So we'll use the color red. Okay, good. So now we'll use plot dot plt dot plot.
Sir,
Now we plot a line. Yeah, please tell me.
sir, here x grid is equals to x grid. Why we need to write this, sir?
Okay, as I told you, like decision tree or the complex algorithms, what it does is it goes into minute level. It divides everything into groups and all, right? So to have a smooth curve in the visualization. Okay, so you remember, right, for uh, PLR plot or linear regressor plot, we are not applying anything, but we are getting the plot like this. See, so this curve we haven't we haven't smoothened the curve actually. That means if you smooth the curve, it gives you a good perfect curve way, right? So in order to smooth the curve and all, now we are digging down into a minimum level. From there we are applying the visualization actually. So that's why plt.plot. This is a prediction line actually. So we are applying the X grid on it. Clear?
Yeah. Okay, sir.
Yeah, that's good. Yeah, X grid, and then we'll apply our color. Blue. Comma and regressor dot predict of X. So color blue, and then yeah, it's done. So that's it. So first we'll plot the graph and we'll see whether it has come up in a good way or not. No, X and Y must have first dimension, but they are shapes. Okay, we'll go with then X. Great. Yeah, see the chart now. So we have a prediction line here. So with the actual data points now, and we are using these the prediction lines. So the same thing, the line, where it has minimum error rate, it is giving us the respective output actually. Yeah. So that's how you can actually visualize the graphs present in our machine learning algorithms. Okay. Okay, good. So now we are done with our decision tree. Once more we'll apply the prediction part, and then let's see whether, yeah. So this is the output which I'm expecting actually. So it has changed a bit actually. So why in the sense, at the time we haven't applied random state, I guess. See, now the value is always 15,000. Yeah, at the time we haven't applied the random state properly. So now the value is always 15,000 actually. So 15,000 is the output that we have got from decision tree. Clear. Last time we have mixed up with PLR, and also it was not giving us a proper output. So now, yeah, I've run it again. Now we got the output as 15,000. Yeah, good. So now we have this 15,000 value actually. So the 15,000, compared to PLR and decision tree, PLR is way better. Exactly. So 15,000, if you check our data frame, check the data frame properly. So you see the level at 6 and 7. Sorry, 5, 6 and 7, right? Oh, it's 6 and 7. 6. Sorry, the levels. Sorry, I'm checking the index 6 and 7. So if it is showing as 1,50,000, if the level is also 6 and still it is showing as 1,50,000, okay, that's okay. But the PLR prediction, it is showing as 1,58,862, which is way more better, a little bit. It's good actually, right? So decision has given you a value of 15,000 now, 15,000, right? So remember, guys, first we have applied the linear regressor curve, which has given us like 35,000 or something, a prediction value, which is like far away from the 6 and 7 levels. After that, we have applied our PLR, polynomial regressor, right, to polynomial regressor, and we got the prediction values 1,58,862, right? And after that, we applied decision tree, where we got the value as 1,50,000. Right, now we are going to apply 2 more algorithms, and we'll see which algorithm is best suited for this data set and all. Okay, let us see. Okay, now the algorithm what we are going to apply is random forest. Okay, random forest is called as ensemble method. Okay, ensemble method is something where you are applying multiple algorithms inside a single program. Okay, like one or more algorithms. Okay, one and more actually. One or not one or more, one and more. Okay, so we are applying like more than two, or two, more than one actually. So it becomes an ensemble method. So what is the algorithm it is using now? So random forest, in the name itself you can see. So this is a decision tree, and this is a random forest. That means you can apply n number of decision trees inside this random forest. Clear? That means if you're averaging the things based upon the amount of information, and here it is applying the best suitable tree, where it is giving you, and it is taking up the average of all the trees, and it is giving you the output. For example, if I'm going to apply 10 decision trees, I can apply 10 decision trees to the random forest directly. Is that clear? I mean, are we okay? Did you understand what I'm saying? That's why it is called as an ensemble method actually.
Okay, sir.
Yeah, good. So ensemble method, we'll look into it. Like same thing for the positional salary data set, we'll apply this random forest also, and then we'll see the prediction value. Yeah, and then we'll come into some conclusions. Okay, the same thing again. If you have the same data set, I'll take the same plot. I mean the same packages. Yeah, I'll copy it. I'll copy it, and then I'll paste it here. Yeah, in between I got a call. Sorry for that. Yeah, so again I'll take this. Yeah, I'll rand.py. Okay, I'll name this as rand.py. Good. That means random forest. Remember, so if I send the rand.py file in the group, we assume that it's a random forest file. Okay. Okay. Now the next thing, we'll select the x and y values. Yeah, it's the same. I'll take each and everything. Okay, good. Yeah, so now we'll apply our yeah, first I'll execute this. Yeah, we have got x and y's, and now we'll apply our random forest. So in order to apply the random forest from sklearn dot ensemble, now we have a module called ensemble. Inside that ensemble, you'll find this random Forest regressor. Again, see, random forest is also can act as a classifier too. Okay, like we can use this for classification purposes also. Like, so the classification in the sense like the entire data is divided into categories. If you remember, I told you the output is divided into categories like yes or no statements, true or false statements, or different car brands or different flower types, something kind of. Yeah. So yeah, while entering into the classification, you'll understand. I'll be showing you some data set and we'll apply all the classification algorithms on top of that on top of the data set, and we'll observe how all the classifiers are working, and we'll look into it. Okay. From sklearn.ensemble, now we'll apply our random forest regressor instead of applying the classifier. So remember, since we are dealing with regression techniques and all, we need to apply the regressors only, not the classification part. Okay. Yeah. So as I told you, like random forest is an ensemble method. It contains multiple decision trees. Like you can apply a number of trees you want there. Okay. So let us see like how to apply that many trees. Like if I want to apply 10 trees, because the data set is so small, right? So I'll apply only till 10 trees. You can apply till 5 trees also. That's okay. But what is the exact? You need to have a clear understanding, like how you will do it. So for that, we have this grid search and randomized search methods, where it tells you the best possible hyperparameters to your particular. Yeah, 1 minute. Someone is knocking my door. I'll be back. Hello. Yeah, sorry, someone was at the door. Yeah, so now we'll continue the class. So random forest regressor. Now we'll see like how to apply our decision trees. So that many decision trees into a random forest. Yeah. So for that, first we'll start creating an object for the random forest. So I'll take a variable. Okay, I've taken a variable now, and after that, I'll apply our random forest regressor. Yeah, it's done. And inside this now we have parameters like how many estimators you want, like how many trees you want. There is a parameter name which they have designed and we are using it. Okay, suppose 10. That means decision trees you are taking 10, and then the random state, same thing, because the value should not change. The values, the data points, what it is taking at the initial state, it should not change. If it varies, the prediction part also varies, right? So that's why it should not change. Okay, good. So now I'll apply my. Yeah. So regressor, yeah, we applied our random forest object on top of my regressor, and now regressor dot fit. That means we are fitting down our random forest regressor on top of this x and y's. Yeah. So yeah, random forest regressor. Yeah, the algorithm we have developed now, and now we are able to predict our result. So again, we'll apply the same one and 1 point, and we'll try to predict the outcome of that particular point. Dot predict or test. Yeah, see, it is showing us like 1,67,000, right? So see, we are still from one algorithm to algorithm, we are moving it is gradually increasing. The prediction is gradually increasing, right? That means now, let us say, so I'll write it down here, hashtag random forest. Ensemble methods always work very beautifully. If you apply more than one algorithm to our data set and all, they apply very beautiful and they give you the best results actually. Okay, but sometimes a simple algorithm can also solve your problem. Why to go with the complex algorithm? That's the question. Okay, so what was the prediction? 1,67,000. So okay, I'm going to uh, write it down here. Good. So let us see the data set again. Yeah, can you see now the sixth and seventh level? it is 1,50,000, and the 7th level it's 2 lakhs. In between, what if we have applied linear regressor, which has given you more than 3 lakhs. Okay, we'll leave that. We'll ignore that. And we have applied PLR, and it has given us 1,58,862, which is way better. And we applied decision tree, it has given us 1,50,000, which is okay. But when we applied random forest, it has given us 1,67,000, which is way cool, right? It is like in between 1,50,000 and 2 lakhs. It is in between, right? Which is a good prediction, which is a good prediction, right? So that means for this particular data set, random forest still no. The leading algorithm is the random forest. We have one more algorithm. We'll look into that algorithm as well, and we will conclude the things. Okay, let's do it.
Sir,
Yeah,
sir, can you tell once that comparison, sir?
sure, sure.
The
Okay. See, we have applied the same data set for each and every algorithm, right? Like, okay, see, so we still know what we have seen is linear regressor curve, multilinear regressor curve, polynomial regressor, decision trees, random forest. Yeah, so these 5. So multilinear regression, why we are not using this? Because it doesn't have multiple inputs. We have only one input here. That is the level. So that's why we are done with linear regressor. So linear regressor, if you have looked into it, we'll see the linear regressor also. Uh, yeah, first we'll apply this to a linear regressor and we'll get that value as well, so that you'll have a clear understanding. So it has given us 33,000, sorry, 3 lakhs 30,378. Yeah, so I'll apply. I'll just type it down as linear regression. Yeah, 3 lakh 30,378, right? And after that, we have seen PLR, the polynomial regressor, where the mathematical formula is different from the linear regressor equation. Yeah, so when you applied that algorithm to our data set, it has given us a prediction value of 1,58,862. Okay, so if you look into the data frame, so what is the, sorry, what was the prediction you were like searching for? It is 6.5. That means you're searching for the salary with the level 6.5, right? Check this. So this is the salary and these are the levels. If you see in between 6 and 7, I've taken a value 6.5, right? So that means it's a new value to the machine. We haven't trained about 6.5 to the machine actually, right? Are you getting it? So we haven't trained a 6.5 value to the machine, but still it is able to predict the, not, it might be the right or wrong, we don't know, but it is able to predict, it is able to approximate to the salary, right? It is approximate the things to that particular salary, which we don't know, which the value is unknown, right? If you check in between 6 and 7, we have given the 6.5 value. Normally if you take the average also, the salary would be like 1,75,000 around. Since it's a small data set, that's why we are able to predict, I mean, we are able to tell the real-time value. But if you have a large data set, then it becomes very difficult for us to get the exact results. But at that time, now you see these visualization techniques and all, and you finalize one data set, one algorithm actually. Okay. Okay. Since we are talking about basics and all, these are sufficient. These are good actually. Okay. Yeah. So now we have applied polynomial regressor, and after applying the polynomial regressor, it is able to predict like the value, the salary for the level 6.5 is 6.5 position is 1,58,862, which is good. Okay, not bad. So it is in between 1,50,000 and 2 lakhs only. Right? It's okay, not bad. And we have applied decision tree there. So after applying decision tree, it is able to predict the value as 1,50,000. Okay, that's fine. But random forest, when you have applied like random, the ensemble method, like random forest on top of our data set, so it has given us a good approximated result, that is 1,67,000, right? So that means when we are moving from one algorithm to other algorithm, at least the prediction rate is improving, right? Which is a good sign.
yes, sir.
Right. Yeah. So now we'll go with the last regressor in the regression techniques. With this, we are going to complete the entire regressors. And yeah, the visualizations and all, I'll be teaching you properly in a better way. Like when we enter into classification and all. Till then, you just understand the concepts of the prediction and the regression parts and all. Okay. So the last and final part is support vector regressions. Support vector regression. Okay. Support vector regression is something where it creates some kind of hyperplane in the dimension actually. That means it is going to create a threshold kind of. So if it identifies that it is away from that hyperplane, what do we say? Like it pushes that point into a particular group. If it is below the hyperplane, it pushes that point into the particular group. Okay, remember these sentences, guys. Yeah, when we enter into classification, for each and everything, we have a clear PDF and all. I'll show you how the algorithm is working in the backend and all. But for now, just remember the statements. Okay, good. So now we'll apply our SVR, that is support vector regressor. I'm going to name it as SVR.5. Okay, the same, since we are going to apply the same data set, the steps are same. Okay, I'll take this and I'll copy it down here. Yeah, again, I'm going to take out everything because, yeah, so we'll start from the beginning. Okay, good. So now we'll, okay, first we'll run the code and we'll apply our support vector regressor. Okay, in the sklearn, we have a algorithm called support vector machines. So support vector machines is SVM. See, it is giving us SVM. We'll import SV. Sorry, we'll import S. What was the name? What was the name? SVR only, I guess. Yeah, let's see. Yeah, it's working, but it is not giving us any suggestion. But well, let's see. Let us like import this and let's see. Yeah, it is not throwing us any error. That means yeah, SVR is the module name that we are going to use, and we have a classifier too for this. Okay, like we have support vector classifier too. So we'll use this classifier in the classification section. Okay, so till now the decision tree random forest and SV decision tree random forest and support vectors. Support vectors. These all, I mean, all these work for regression as well as classification also. Okay. Now we'll create one our SVR object, and then we'll use it. Okay. This SVR uses some kind of activation functions like sigmoid, which uses our trigonometrical functions and all. So first we'll just use a sigmoid function and we'll apply our regression. We'll try the prediction results and we'll close the sessions. Okay. For that we'll use regressor is equals to SVR kernel. Yeah, is equals to sig kernel equal to RBF. See, we have like so many filters out there, but I'm going to use the sigmoid function for this, which is a like famous function. People use it like for this SVR and all sigmoid, the first thing which they come up in their mind. Okay, so we'll use it. We'll use that only, and we'll apply this. Yeah, so we have got the object of the SVR. Perfect. And next step is we need to fit that with our x and y values, right? X comma y. Yeah, good. So I applied it. Yeah, so we have successfully created our regressor, the support vector regressor, and now we are going to predict the value of 6.5 for this. There it is. I'll take this. Yeah. And if I apply the prediction part, see, it has given us 1,29,000. Okay, so I'll save it. I'll go here. Yeah, so here I'll be writing the name. Okay, so now we have these values. Okay, that's what I was talking about. Like you need to understand which algorithm is best suited for our data set. Can you tell me which algorithm is best suited for the data set from these results? Like what are the conclusion? What is the conclusion?
Support vector regression, sir.
Support vector. Okay, let us see. Again, I'm going here. See, from 6 and 7 we have. So 6 is 1,50,000, but support vector has given 1,29,000, right? We are asking for 6.5.
Yeah.
So the nearest close one, the best one is the random forest, right? 1,67,000. So if you take average also, like think of a small mathematical calculation like an average. In 6 and 7 we have 6.5. If we take average of 1,50,000 and 2 lakhs, what is the answer? 1,75,000, right? So this is the one which has given you the nearest approximation. That means random forest is the best suited algorithm for our data set. Clear?
Yes, sir.
Yeah.
Sir,
So
it means
it means that we can. Sorry, what was that? Hello.